Hello Dev, welcome to the channel. In this video, we're going to discuss the Decorator Design Pattern. How do we implement it? When should we use it? What is the Decorator Design Pattern? Let's get started. It is a structural design pattern that allows us to dynamically attach extra behaviors to an object. It provides a flexible alternative to subclassing or adding new behaviors to an object by preferring composition over inheritance. What are the elements of the Decorator Design Pattern? First, we have an interface for objects that can have new functionalities added to them dynamically. Then we have a concrete component that implements that interface. We define another class called base decorator that wraps the references to the interface type and delegates the work to the concrete decorators. And of course, we have the concrete decorators that are the classes that attach new behaviors to our existing component. Let's take a look at the class diagram. Here at the top, we have our client code, which in our case is the main method, making use of the iComponent references, more specifically, the instances of the concrete classes that implement that component interface. That defines the base behavior and the rules for our components. Here on the left, we have the concrete component, which is the one defining the base behavior of our component. To the right, we have our base decorator class. Note that it's an abstract class, because we're not going to instantiate that one. We're actually interested in the concrete decorators, which extend from the base decorator. In the diagram, you can see multiple subclasses, just to demonstrate that we can have more than one concrete decorator. Still in the base decorator, we can see the reference to iComponent, which is going to be the one wrapping the concrete decorators that allow us to add the extra behaviors to our concrete component. Let's take a look at the code. Here in the IDE, we have the decorator project. Let's take a look. So first, let's talk about the structure code, which is the one reflecting the UML diagram we've just seen. In our main method, if we run it, we can see the output. So first we have do this, then do this, but also do this, but also do this. Don't forget doing this. So the first line of the output is the one matching the concrete component, which is our base behavior. So here on line 11, we have a reference to iComponent, and we instantiate the concrete component. Then we invoke the method do this from the concrete component reference. If we go to the concrete component class, here we see the method do this being overridden from the interface iComponent. If we go to iComponent interface, we can see the definition of that component. Back to the concrete component, it's just a simple method printing a string. That's the base step of our application. Now we're going to start adding new behaviors to our concrete component. We have another reference to iComponent, which is concrete component with decorator. Notice that now we instantiate the decorator first, and as an argument to the concrete decorator, we have a new instance of the concrete component. Let's go to concrete decorator. So our concrete decorator is the one responsible for adding extra behaviors to our concrete component. Concrete decorator extends from the base decorator, which is the starter point for the decorators. So before diving into the concrete decorator, let's take a look at the base decorator. The base decorator class is an abstract class that implements iComponent. It has a reference to iComponent, which is responsible for invoking that version of the behavior. So if we go back to the main method, so when we see the concrete decorator being instantiated with an instance of the concrete component, we go to the concrete decorator. You see that the constructor takes a reference of iComponent, which in our case, we passed the concrete component. We call the super constructor, which takes us to the base decorator constructor that also takes a reference to iComponent, which again in our case was the concrete component, which is the first time, assigns it to our reference variable, And when we call the do this method from the concrete decorator, which one gets executed first? That actually depends on the concrete decorator. The concrete decorator has the do this method. It first calls super do this, which goes to our base decorator. Do this method. What was the reference we have in the wrapped variable? The concrete component. So it invokes the concrete component version of the method do this, as you can see in the second output line. Here in the main method, we can demonstrate that with this part of the code. Can we swap them around? So if we go to the base decorator, it calls do this from this reference variable. Back to the concrete decorator, we can just swap those lines and we run this. First output is the concrete component only. Second one is the concrete decorator. But look what gets printed first. But also do this, which in our case is the concrete decorator extra behavior of the do this method. So inside the do this method, we're adding something, adding an action. We could invoke another method. We could have a chain of other methods, adding behaviors to the concrete component. So when we call the super do this, it goes to, again, base decorator class. Back to main method. In the other example, we go one level deeper. Another reference to iComponent, but now we're gonna have another decorator. So we instantiate the concrete decorator other. We instantiate as an argument of that concrete decorator other, we instantiate the concrete decorator. So we pass that reference, and then we pass inside the concrete decorator, the concrete component. You can see that the inside argument, or let's say the most nested one, is the base behavior, which in our case is the concrete component. So when we call the do this method from this big variable here, all of the methods do this get invoked. I will just go to concrete decorator and swap this back, save this. So when we run this again, we can see the original do this, but also do this. So it is in the original order. And then we see in the third example, do this, but also do this. Don't forget doing this, which we haven't visited yet. It's the concrete decorator other. Same structure of the concrete decorator. So all concrete decorators, they're gonna have a similar structure. Let's take a look at another example. In my project list, I have the sample decorator package. And here we have run decorator sample. Let's say you have an application that sends notifications to users. Different users want their notifications through different types of systems. One user wants the email version of the notification. Another user wants a Facebook notification. Another user wants the WhatsApp notification. But the base behavior is sending the email notification. I also want the other app's notification. We can decorate our notifier object. Let's take a look. So if we run the main method, we can see sending like and subscribe by mail to Peter@mail. By the way, hit the like button and subscribe to the channel. So this is the first base behavior. So at the first two lines here, we see a reference to iNotifier, which is going to be our interface. Instantiate new notifier. It takes one argument, which is a string. Let's take a look at our interface first. iNotifier defines the method send with a string message, and it also has the get username method. This is to simulate retrieving from the database. Back to the main method, from our reference notify mail, invoke the send method, sending this message, like and subscribe. So here we see sending, which is coming from somewhere else, like and subscribe, which was our message, how it was sent, and to who, which was the username. So if we go to our concrete component, which is our notifier, we see notifier as a reference to a username, database service. It's just a class simulating the behavior of a database, not actually connecting to it. Here we have a method, get mail from username. So we're passing the username, we're forcing that. So username at mail. So you can see which is the one right here in the output. Then you have get phone number from username. We're going to see those shortly. Back to our notifier. Here we have our constructor, and here we have the overridden methods, which first is the send method that takes a string, goes to the database service, retrieve the mail from the user, which again, sending by email is the base behavior, assign it to the variable, and we print that message, which we've seen in the output. So sending the message we typed in the client code, which is our main method, by mail to the email we retrieved from our fake database service. How do we extend the behavior of this notifier to send different types of notifications, or better saying, through different applications, without directly extending the notifier? Otherwise, we could have lots of derived classes. Because let's say you want separate notifications. Sometimes you want notifications in the 3 systems. Sometimes you want notifications only through mail, sometimes only through 2 systems. So we define our base decorator class that lets us add the extra behaviors to our notifier. If we go to the base notifier decorator, you'll see a similar structure to the sample structure we've seen before. So it's an abstract class, we cannot instantiate, implements, follows the rules of our iNotifier interface. It has a reference to iNotifier, so it wraps it up inside. I'll skip the database service, which we've talked before, and the initial constructor that takes one iNotifier reference. So we have to send something that implements iNotifier. In our case, we already have the concrete component, which is our notifier class. So once we send it here, it initializes our base notifier decorator. When we call the send method from the base decorator, which it's an abstract class, so we have to call the one from our children classes. It has the nested wrapped reference here. So if we go back to the run decorator sample, let's take a look at the second example. Reference to iNotifier, and we instantiate the Facebook decorator. So now we're going to send email notification plus the Facebook notification. If we go to Facebook decorator, it is a child of base notifier decorator. We see the constructor that has a reference to iNotifier. So again, from the main method, so in the Facebook decorator constructor, we passed the new notifier instance. Back to Facebook, it's right here, gets passed to the superclass, which has the reference also to iNotifier. Once we call the send method, our beautiful super keyword here. We call the send method. It's going to invoke this part first, which is the base behavior. And then, of course, after it sends through the base behavior, keeps going the next 2 lines. So it retrieves from the database, the Facebook name from the database, and then it sends a message on Facebook, the message we type right here. And it goes on. If you want to add extra decorators, we have to extend the base notifier decorator. Last but not least, now we have one level deeper, another reference to iNotifier. Instantiate the WhatsApp decorator. Let's take a look. WhatsApp decorator has one initial constructor that takes a reference to iNotifier. So I have to create it, I have to instantiate it with one reference, with one object, iNotifier, which I know that the Facebook decorator, it's also an iNotifier object. It extends from base notifier decorator. So how is it iNotifier? Because iNotifier is implemented by the base notifier decorator. So the WhatsApp decorator gets created with an object of the Facebook decorator. Facebook decorator also has to be created with an object of iNotifier, which now is the base behavior. We're not going to use another decorator. We're going to use the base behavior at the deepest level. So here we instantiate the new notifier, pass the username. Once we send the message, first the base behavior, then the first decorator, then the second decorator. With that, we come to the key points. Flexibility is the biggest one of them all. We add extra functionality to objects without changing the structure of their code. With that flexibility, we follow the open and closed principle. It is extremely useful when we cannot extend an object's behaviors through inheritance. The downside is that it can lead to lots of small classes, increasing the complexity of our application. That was Decorator Design Pattern. Let me know if you have any questions in the comment section down below. Hit the like button and subscribe to the channel. Your support is extremely important. I hope you enjoyed this video, and I'll see you in the next one.